Hello again. Alright, so this time we don't have to deal with the projector being dead. We can go through this the way it should have been done. So our goal of the day, we want to talk about testing and how it can actually be good. And before we get started with that, we will talk a little bit about some key keywords here, keywords, yes, that will enable us to do everything we want to do today. So let's suppose we have a class here up top called Hello Mini. And its whole goal is to print out hello some number of times, similar to what we saw in lab. And in this case, it gets its number from the helper class. It says, hey helper, square 2 for me. And helper will oblige by using its square method and return a square. So you guys being good at math can predict probably that if we pass 2 to this thing, we get back 4. Now a note on syntax real quick. If you're ever calling a method inside of a class, that is part of another class, that is Hello Mini wants to use a helper's method, we use the syntax name of class dot name of method, and we will get used to this more formally next week. Okay, so this program, as you might imagine, it prints out the word hello 4 times, and if you run it, which I will not do live here, but if you run it, we get hello 4 times. All right, so the key thing I want to point out here, the reason we're doing this, is I want to talk about this word public here that I've circled and say, what is the point of it? And as it happens, it's actually pretty simple. And it just means that this method here, square, could be used by other classes, right? So what does it mean? Like, what do we mean exactly? Okay, we'll try changing public to the opposite, namely private, and see what happens. Okay, so in this case, you might naturally assume it means it cannot be used by other classes. And indeed, if we try to compile this thing using make, it will yell at us, the compiler, and say, hey, square is not something that you're allowed to use. That's part of helper, and helper has decided that's not cool. So you might ask yourself, why would I do this? And that's a great question. Because, for example, if you came from Python or Scheme, you know, it doesn't support something like that. So what is it about Java? Well, Java is a language which is often used to build huge projects that tons and tons of people are working on. And so we want to restrict access to classes. With the core idea is we want to hide implementation details. So if I write helper, it may be that I don't want someone else to know about square. And I'll have a kind of hokey analogy involving cars in a moment. But the basic idea is that we want to have less for the user of our class to understand. So someone using my class, I want them to have to know the minimum amount they possibly need to know. And that's good also because it means that I can change freely all the little details under the hood without you worrying about it. So my hokey car analogy that I hope will bring it together, you can imagine a car basically has a public interface, which is the pedals and the steering wheel. That's the world-facing part of the car. And then there's private stuff that happens you don't think about while you're driving that is nonetheless happening while you're being conveyed by a robotic death machine powered on ancient fuels, right? These, for example, a fuel line, right? So somewhere when you're pressing a gas pedal, there is more fuel going through a line. And you can imagine, we could have made the interface for a car totally crazy, and like you just hold a hose of fuel and like have to pinch it to control your speed. That may be unsafe. I don't know. No one's tried it. But by hiding those details, right, it means that nobody has to learn how to control their speed by squeezing a hose. And it also means that if down the line you decide fuel's not so cool, like we switch over to maybe some hydrogen-based thing where there's not a liquid flowing through something, I don't know, solar, whatever, that means that we can get rid of that altogether and still leave the pedal as the interface that you as a driver will use. Now I'll mention that despite the term access control, I'm calling it restriction of access. It has nothing to do with trying to keep you safe from hackers or whatever. If someone is already has your source code and is running it, then I mean whatever, they already won, right? There's nothing to protect against in this case, so don't be fooled. It's all about hiding implementation details. Okay. Now I'll mention that's not the whole story. There's actually many more levels of access, well, 2 more. All the way from private to public, and we're not going to talk about that at all today. It's not just functions, or sorry, methods, either way, that we can protect, but also classes themselves can be considered private or public. Okay, but that's a thing we'll talk about later. Okay, so why does all that matter? Well, we're going to be building obviously, I don't know, if you want to try and convey questions to me through time travel or something. No? Okay, cool. So we'll continue. So the reason we care about those is what we're going to do today is build a class that's going to provide two, I'm going to say public methods for clarity. And these are going to be basically like your steering wheels or your gas pedals, right? And we want people to be able to ask our helper class or our class to sort an array of strings, or to be able to call main and print out command lines in sorted order. And you know what? Main also happens to take an argument, which is an array of strings. Okay. And so our approach for the day in building this class is we're going to write tests before implementation. And so those of you who are actually on 61B, you've gone through and done labs this week, and you saw that this was an annoying process. You had to write these files, one called tests.command or CMD, another called test.out. You had to manually type out everything that the program was going to spit out. So that's just annoying to have to type literally what the program's supposed to generate. And so we're going to see a better way than doing that. So let's get going on that. All right. Now, actually, I should bring up an important point before we do that, which is these first few weeks of 61B, we're going to be using a lot of tools and things about Java syntax without really knowing what's going on or really fully understanding them, and that's fine. Like, we shouldn't freak out about that, and we're going to see that to the extreme today, especially towards the end. So don't panic. You know, over time, these things will all be unveiled. For now, we just need it. You know, one of the things about using a language like Java, which is object-oriented to the core, is that we have to deal with those facts, even if we don't really understand object orientation, which is going to be a lot of the focus of next week. So let's get started by writing out with our sort class. And I am going to suggest that maybe our class should be called sort. Seems like a good name. And I'm going to start that class off by using this little trick. That was odd. Let's try again. This time it's called sort.java. I swear Sublime does that. It's like it doesn't do the same thing every time. Blows my mind. So somehow it worked the second time. In fact, I would be so tempted just to pause this right now and watch it. It's the first time I've ever caught it in action. So Sublime author, be aware your program behaves non-deterministically. Anyway, okay. So back to the point at hand, we want to generate or build this class called sort. And I don't want to type out all that stuff that we always have to type out. So I've actually set up a little macro here in Sublime where it sets up the basics for me. And you know, at some point soonish, if you're curious, I will post this for you to use. But it saves me some trouble. So what is my class called? Well, it's called sort. What does it do? It provides a method for sorting arrays of strings, as well as a main method that shows off its power. All right, we'll be a little flippant here, it's fine. And likewise here, the main method, so what it's going to do is prints out the sorted, prints out the command line arguments in sorted order. Here, sorted means lexicographic order. So that's same as a dictionary. And here I mean like a literal dictionary, like Python dictionary. I mean like, you know, you look up the word cat and right after that is cats, or I don't know. I don't know how dictionaries work. Physical books, yeah, whatever. Okay, so that's one of the methods we're supposed to provide according to our comment up here, our document comment. So I'm going to add the other one here. I'm also supposed to provide a method for sorting arrays. So we'll call that one, it's going to be public static void sort string. In this case, I'm going to call it A for brevity. You know, here, I mean, I could also, by the way, whenever I use a main method, I mean, I could call this like horse or whatever, but convention is to use args. But here we're not bound by any convention. It's our method, so we'll do whatever we want, as long as it's not breaking the rules of how Java variable should look. But yeah. Okay, so we're going to create a dot comment for this thing, and we will say sorts A, or puts A in lexicographic order. And we won't say very much else. I will mention we did make a design decision here. Note that we're not returning a new array of strings. We're taking an existing array of strings and putting it in order. So that's a thing we've decided to do. That's the interface we have decided to provide. Okay, and that's us getting started. Now, if we wanted to write this main method here, it seems pretty natural that if we wanted the main method to do what we claim here, what we ought to do is, I don't know, sort the arguments, and then we're supposed to print them out, huh? So I will pass the buck over to a method we have not yet written called print. So again, doing the same kind of thing we did last lecture, we'll just keep grinding out these methods without actually writing them. So I'm going to say private static print string. In this case, again, I guess I'll do A again. And we'll write this later. In fact, we're not going to write it during the course of this webcast, but we'll need it. And here, this prints the array A. All right. So that's print. Anything weird here? Yes, I forgot to put void. All right. Why private? Well, the reason that we're making it private is because we've decided up here arbitrarily that the only thing we want to provide to the user is the ability to sort and the ability to provide command line arguments and have them printed. We are not in the business of providing a print method, right? I mean, this is something we need, but we don't want our class to be the go-to class for printing, right? So leave that aside. So that's sort. So now what we're going to do next is we are going to jump right into writing a test for sort. So I've claimed that it can be a good thing to write tests before you even write the code, and we did a little bit in lab 1. So let's try it out. So this time, rather than, I guess what we did in lab was something like, okay, create test.out and all that. We don't want to do that this time. I want to be able to test. There's a few reasons. One is I want to be able to test this sort method directly without having to rely on things being printed out at all. And another thing is I want to actually write Java programs that do testing because it's just less arduous. So let's create this class. It is called test sort. Let's see, it's tests the sort class. And here tests the sort class. Okay, it's good enough, you know. In real life, we probably write better comments than that, but it'll do. And I'm going to suggest that for the sake of modularity and keeping things nicely encapsulated, that I would like to create a function called test sort that will test the sort method. And, you know, we may decide, I don't know, maybe it'd be a good idea to throw in some more tests later, but for now we just want to test sort. So let's set this up. Again, we still haven't really done anything, right? We're just setting the stage. So private static void test sort. And this function tests the sort.sort method. All right. So what does it mean to test a sort method? Well, probably what I want to do, you can imagine, is I want to take something, send it through sort.sort, and make sure it is what I expect. All right. Now this is obviously not Java code, but that's what we want to do. Take something, put it through sort.sort, and check that it is what I expect. So what we need to do first is set aside a something to be sorted. So let's try that out. And I'm going to say here string. So my goal since sort is, well, I guess, okay, sorry. We're going to have to create these things. And eventually we're going to sort whatever our something is, right? So our goal is to create a something. That's our next little mini goal here. Okay. So we want to create an array of strings somehow. And in this case, we somehow need to make a dummy array, right? We don't have any kind of parameters. We don't want to ask the user for something. We're just throwing together an ad hoc test. So I will use the one we used from our first lecture because I thought it worked pretty well. It was potato is our god. All right. Now this thing right here, the hope is that this thing will actually be a string. And again, this is an example of probably a bad way to program, where you're just like, I'm going to assume this is how I create an array of strings in Java. And if we try and compile this thing, we will, it is no big surprise, find that this does not work. So the question is, how do I create an array of strings in Java on using a literal? That is, I mean, I could do it perhaps. Well, actually, we don't really even know how to do it, right? We don't. We haven't talked about declaring arrays. All we know at this point is that they exist. So this is what the syntax looks like, and this is going to be. Remember earlier I said we're going to use things somewhere around here. Yes, we're going to use things that we don't fully understand, right? So this is going to be one of those things. I'm going to say to create, this would have been the equivalent Python syntax. To do this in Java, what we're going to do instead is new string, open bracket, close bracket, curly bracket, close curly bracket. And that will give us a string. And I just ask you to trust me. I don't want to go through and try and verify this, right? So we look at it. It says cannot find symbol sort. Oh, okay. Well, what do I need to do? I guess if you're watching this online, what do you think? Pause. Okay, cool. Yep, we need to do sort.sort. And now it compiles, so I'm in better shape. All right, what's next? Well, we want to go through and check that this does what we expect. So much like we did whenever we did the tests.out file, I'm going to hard code what I expect to happen. So in this case, if we sort this thing manually, we would get God is our potato. All right. So that was what we expect. Now I threw together this word something earlier. I don't like it so much. I'm going to change it to input really quickly. Okay, and so now we have an input and an expected. And now what we want to do, I'm going to write out as a little comment. We want to compare input to expected. And if they do not match, we want to, I guess, warn the person running this test. Right? It's kind of an interesting point. Whenever you write a test, like, it has to do something. So it could print something out. It could send you an email. I don't know. It could shoot flames into the sky. Whatever seems appropriate. But we'll go with the print statement. Seems like a pretty safe option. Okay. So we will say with a print statement. Okay. So how do we compare these two arrays? Well, we don't know a lot about Java. You might imagine there's some way to compare these directly. And I'll suggest that one thing we might be tempted to do is just use the equal equal or the not equal operator that we've seen. So we could, for example, maybe say if input is not equal to expected, but I'm just going to stop us right there, and I'm going to say this is a terrible idea. So I'll just write, no, this is a bad idea. And the reason is that not equals, whenever we're comparing two arrays, does not do what you expect. If you happen to know Python pretty well, you can think of, so equal equal in Java is similar to is in Python. Now, I mean, if you don't know Python well enough to know what I'm talking about, that's fine. I don't expect you to. But if you know, that's what's up. But the moral of the story is that comparing arrays like this is just not a good idea, and we'll learn next week, I think, why that is. Okay, so we're gonna sweep that under the bridge and say no, not a good approach. We're gonna have to go through and do things from scratch. So if I want to compare these two arrays, how do we do that? Well, the first thing we might do is check that their lengths are the same. So we might say if input length is not equal to expected.length, then we want to say something. So we might say, okay, hey, lengths of input and expected do not match. Maybe that's not super useful to the user, so we'd say also something like, I don't know, input input length is input length. Okay. Reminder, by the way, that YouTube videos can be double speeded. So if I'm going too slow for you, click that little button on the bottom right. Speed me up. Okay, so we have expected length is this. Compile real quick. Okay, that's good. And you can imagine writing tests like this. Now I should mention that one of the meta goals of this whole thing you've been watching, which I should have set up here, is that we want to experience the pain of ad hoc testing. All right. What we're doing right now, it's clear that we're reinventing the wheel as we go. I mean, you and I both know there's probably a better way to compare arrays, we can also imagine that probably somebody out there has already thought about this problem and maybe implemented it. And so that instead of having to write all of this code, right, there's probably a better way. We'll see it in a moment. I'd like to mention just a little bit more about why this is painful. Because at this point, all I've done is compare lengths, but I've not actually compared these two arrays. So I need to go through each individual element, and I might end up writing a loop that starts looking something like this. Okay, so then I need to do like compare AI to, or not AI, input I to expected I. And in a hurry, it becomes clear that this is not a time-saving endeavor, right? So the whole point of testing is to make our lives better. But note that, you know, we're, I don't know, 20 minutes? I don't actually have a timer. Who knows? It's still Friday, so that's good. We've obviously spent a ton of time. We haven't even gotten anywhere near writing a sort yet. We are still writing a test. This is taking too long. We're having to make too many decisions. I don't like it. All right. So this is the point where you might be tempted to, if you were writing your own tests, and perhaps, I don't know if you've ever tried this, but when you're writing your own tests, this is the kind of block that you hit where you're just like, okay, this is a waste of time. I'll just use sort.main to debug, or to verify correctness, all right? And maybe in this case, since it's such a small class, that won't be that big a deal, but for bigger classes, it could be a problem. And I think that during this time, you will hopefully see why it could be really useful to write tests even for this small sort class, why it's not a good idea just to rely on sort.main. Okay, so what we're going to do is all of this suffering that we've just gone through, all this thinking here, we are going to use something that's going to do everything for us like magic, right? So goodbye. Instead, I'm going to call a special method, and it's called org.junit.assert. Assert equals, and we're going to give it expected and input. And we are done with our test, okay? And what it's going to do is exactly what this comment says. It's going to compare these two things, and if they don't match, it's going to do something useful. So let's try running it. Okay, so let's now invoke it, the command line, and we see, all right, cool, we're getting some information. Our test fails, as we expected. You know, we expected God, and we got potato, right? And yep, that makes sense. That's what we expected to happen since we have not implemented sort yet. Now, what's nice about JUnit is not only does it tell us what the problem was, but it tells us exactly what line of code everything messed up on. So we can go and look, okay, line 19. It's this test. Okay, so I know what to go for. And if we have our environment set up, say we're using Emacs or something fancier in Sublime, I can actually press a button that'll send me straight there. But that'll be a thing that if you really want to optimize your workflow, that you can do. Not today. Okay, so that means our test is failing, and that's awesome, right? Now we've finally gotten to the point where we have a test that is functioning, right? So I want to talk a little bit philosophically about why this is an achievement and why we have not wasted time. So let's talk about exactly what we've done so far. So we have this sort method, or sort class we want to create. And the main thing it does is it provides this sort method, and it has this print one that we're not going to actually write today. And before we ever even wrote this thing, we created a supplementary class here that we have a test sort method that is going to make sure that sort works, right? Now, the key thing is that after you get good at using JUnit, busting this class out takes no time at all, especially if you're using something that auto-generates all that boilerplate, right? Where you don't have to type public da-da-da-da-da-da-da-da. And so you can have that test ready in no time. And once you have it there, it's really great because it allows you to, as you go, build confidence in like all the basic pieces you're building, right? So maybe we're going to build sort to be a bigger class later, or something else is going to use sort. It's nice to be able to say, hey, we feel really good that sort works. And we'll see that in action in a little bit once we start implementing sort. The overall goal in all of this is to decrease the time you spend, largely because you're saving time debugging. You get other benefits, but the entire point of this is that we want to save time. And I guess another side thing that's nice is that by writing test cases, we help clarify what the task is. So for example, here we know exactly what sorting is, right? We had to think about what it means to be lexicographically sorted. At a glance, you might have expected it to be something like, is God our potato or whatever, right? Because this word is shorter. But what we've done now is given a nice, crisp definition to what we're going to do. We had to really think about it and really understand the problem, which means that when we go back and write sort, we have a little more confidence we're going to do it correctly. Now, we wouldn't necessarily want to write test code for everything, and we'll have examples in a little bit of when we don't want to write test code. And the reason is that building tests obviously take time, right? Doing this takes time. And a test is only going to be useful to you insofar as it's going to save you time overall, right? So it's just a thing you're going to have to feel out doing it on your own. Now this cycle, or this development style that I've been discussing, both in lab, and you'll see it in homework 1, and now a little bit in lecture, is called test-driven development. And it's a very capital TDD thing. Like this is a philosophy that is very popular in certain circles. And I'm introducing this not because in 61B you have to do TDD, but because it's meant to be a counterweight to or counterpoint to the kind of development you might have done in the past. So again, just as a quick reminder what test-driven development is from the lab, you identify something you want to do, you write a test that tests that feature, like we wrote test sort. You verify that that test fails, right? So we go into the red zone. We write a test that fails. Then we write a code that passes the test, and we celebrate. And I don't know, whatever is appropriate in your culture or religion, we do that thing. And this is great. We were able to certify that our implementation is like, boom, this is good. We feel great about it. And if we'd like, then we can go through and refactor the code. So maybe we have a big, ugly mess that works, and we want to clean it up. In 61B, if you're using test-driven development, at least at the beginning, there's not going to be much room for refactoring. But with bigger code bases, it makes sense. So again, it is not required that you do this in 61B. I don't mind. I'm not going to tell you how to program, but I am going to say that this is one way to approach problems. But I hope I could convince you at least that testing is a good idea. I'll mention, by the way, that there is a GUI for JUnit where they show you a little red box here that tells you you push the run button, right? It's very like visceral. So you click it and it's red, and you're like, oh no, I can't. I gotta keep working on this, I can't get out the door. Or maybe it motivates you. Like I gotta beat this thing. And then eventually, after you've written the test enough and press run again, this thing turns into a brilliant green box. And apparently that high, the test-driven development high, is very addictive to some people. I myself have not tried out this GUI, but maybe you can try it out. So again, this is one approach to programming, but I want to contrast it with something you may have done in the past, right? So I'm going to call this the naive workflow. I see this very commonly with people who are learning to program. In fact, I do this, well, not to this degree, but the example I'll show you in a moment, I've done this somewhat recently. What we want to do, or sorry, what people often do. I think this is called weasel words on Wikipedia, by the way, or in the world. So novice programmers I've seen have sometimes done this, where they'll read the spec, and having read it, they'll write an entire program, 200 lines of code. Then they press the compile button in their IDE, and they find, okay, well, I have 47 compile errors. Go through and fix those. Cool. All right, I guess I'm 66% done. Wrote the program, compile, now I just got to get rid of the bugs. And then what will often happen is you'll hijack your main method and run it and see what the problem is. And you add a bunch of print statements that say like, hey, I got here, and like, hey, I really got here, or like, reached this method. Or there's this very cute thing where you're not really sure where the bug is exactly. So you have print statements, and then you do the binary. You're like, okay, it wasn't there, so I'll go back 10 lines. Maybe it was there, and you do that thing. And what you end up with ultimately, whenever you try and debug something, is code that looks something like this. All right. And I bet almost everybody out there watching this who has programming experience has done this. And I myself have certainly written debugging code like this in the last year. Often it comes from the fact that I think to myself, okay, this is going to be so quick, but often it's not so quick. And the worst part is you build up this huge amount of scaffolding. Actually, when I first started learning to program, I loved building the scaffolding. I was like, it's cool. It's like you get your elite team of people coming in and like, you know, wiring up all this crazy stuff to detect problems. But over the years, it has grown tedious. And the worst is whenever you put all that scaffolding in, find the bug, and then have to strip it all back out. All right. So I'm going to say that this workflow, you know, at first it can be kind of fun, I guess, but later you'll realize that it's really slow and it's really unsafe because the type of testing you're doing, it's, you know, the tests are all wired in. You go find something, and then you pull it all back out, and then like you lose all the benefit, all that work you did, and it's going to make it a lot harder to ensure and feel confident that your programs work. I think that's a real important thing about tests. You know, they build confidence that the basic pieces work. You know where to start looking when there's a problem, right? You can say, I feel so good about this basic thing that I need to look somewhere at some higher level, right? So as a contrast, on the left, we see, okay, this is the kind of workflow that you might have done in the past. On the right is an extreme, total opposite workflow, right? And so what's best for you? Maybe somewhere in the middle, right? So all that philosophy aside, let's continue with something close to this process and see how it can help us. All right, back to the task at hand. So we'll set aside philosophy and return to the material world of code. Okay, so let's start working on sort, all right? So we need some way to put things in order, and I'm going to give you guys a technique known as selection sort, all right? So the idea behind selection sort, it's a fairly intuitive way to put things in order. Here I have 5 things. And the procedure of selection sorting consists of looking at a bunch of items that are all initially unfixed, all right? I mean, we haven't fixed them, right? So I guess they're unfixed, and we'll talk about what fixed means in a moment. And we're going to scan through and say, who's the smallest? Okay, well here we have the right part of our brain to identify small things. It's this one. So he's the smallest one, and then the next thing according to this procedure is move it to the front and fix it. Okay. So I move it over here, let's say, and there it is. And here when I say the word fix, I mean in the sense of keeping it in one place. It's permanently going to stay there now. And just as a reminder for you and me, I'm going to fill it in with green now to say you are fixed. We should not move this again. And then what we're going to do is selection sort the remaining unfixed items. So I have all these. All right, so we get to this block, and we see, oh, okay, this guy, he is the smallest, doesn't need to move anything, so we'll just fix him. All right. Now we scan through and say who's next, all right? So we find this block and say now she is the smallest. So we're going to move her over here into the leftmost spot, and now she will become fixed. All right, and then next we have this block, no need to move, so fixed, and finally this block, same deal, fixed, okay? So everything's in order, and hopefully this makes a little intuitive sense. By always putting the smallest thing at the far left and never letting it move again, everything's going to end up in order. An alternate presentation of the idea here, if you want to try and convince yourself of a different proof of correctness that's a little bit more rigorous, it's here. But in the interest of, I want to focus in this webcast on the tools and on the philosophy. You know, if you don't fully believe me, you can think about it, pause here, and definitely stare on the screen and then feel good about it, and then come back. All right. So we want to now implement this procedure, selection sort. All right. So we'll write out the code in this little pseudocode style here and say, okay, to selection sort means find the smallest unfixed item, move it to the front, and then selection sort the the remaining unfixed items. So I should also say, and fix it, right? So we'll talk about how we'll do these in a moment, but I want to focus on this for the moment and talk about how we would do that. So obviously the way I've phrased it, I'm stating it as a recursive problem. I mean, you can write an iterative selection sort just fine. In fact, I'd say most selection sort implementations are iterative. But again, I want to I want to build our comfort with recursive programming. So we know that whenever we sort, that when we're done with the current step, so we'll have some stuff, that the final step should be something like sort A and then something plus 1 or something like that, right? I mean, that's just the texture of what this code usually looks like. Now, one thing we'll note is there's no parameter in sort, right? And why is that? Well, it's because that's the contract we gave the world. We say, hey, I have a really simple sort method. How do I use it? Well, you just put the array inside sort, and everything gets sorted. So what I don't want to do is try and add a new parameter here that says some number, right? That's no good. So I'm going to invoke a very common design pattern or implementation pattern whenever you want to implement recursive, or to do recursive implementation of a public method that clearly doesn't have the right parameters. And that is to create another method. All right, we love doing that. So I'm going to create a new method. I'm going to define it. I'm going to give it the name sort. It takes in as an argument an array of strings and int start. Okay, and all this stuff is actually going to happen now in this method. And this right here, whenever someone in the real world, well, I guess I should define what start is real quick. Okay, so what does this function do? It sorts the array A, but starting at start. All right. In other words, everything to the left of start is fixed. All right. And that just means that my code should never touch it. It shouldn't be moved. It shouldn't be looked at. Whatever. It's just all over there. If this is the case, if I want to sort the array sort the array A, but starting at start, how would I sort the entire array? If I want to make a call here, well, I'll say sort the array A and start from the very left, and that will do it, right? This is a very common pattern. May as well get used to it because we're going to be seeing it a lot more. Now, there's an important question that might come up, which is, that seems weird. I have two functions with the same name. Well, Java lets us do that, and whenever you make a call, the compiler is smart enough and the interpreter to actually call the right thing. So when I do this, I know that this function, because it has these two arguments of type string and integer, that it will get called, and it's not going to try and recursively call itself somehow, right? So it actually is aware of the parameters you pass it. Okay, so let's continue with implementation. And let's say I want to now do these tasks. So task 1, I'm going to do to pass the buck to another function. I'm lazy, right? It's always good to be lazy. Pass things over to another function when I don't have to deal with that. It just sounds maybe just slightly tricky. So I'm going to say int mindex, cute name, right? Get, what do I say? I'm going to cheat real quick and look what I called it. Okay, index of smallest. And so what index of smallest is going to do is the process basically what we did here, and we were looking for our small thing. Say that this is, they're all fixed right now. We'll go back a couple real quick. I'm going to unfix these. I know it's breaking the rules of selection sort, but don't worry. I'm a professional. Okay, so if we're at this point, when we look for the index of smallest, these are our two unfixed items. It would return this one. So this would be our So the index of the smallest unfixed one in this case would be 0, 1, 2, 3. All right. So we ran it in this on this array. The index of the smallest thing here among these two would be 3. Okay, so that's going to be our index of smallest function. And so I'm going to write it out here and say, okay, we need private static int index of smallest string a and start. And I should put a comment here, which says returns the index of the smallest item in A. In this case, when I say smallest item, I should say lexicographically smallest string in A, really. Starting from position start. Might not even be a bad idea. We'll waste the time because you might be able to watch me on double speed. Might not be bad to have a little example here, which says something like index of smallest on an array. And I'm going to use pseudo syntax. I don't want to write the real thing. Maybe, you know, BA, we'll use real words, it's more fun. Cow, apple, fit. I don't know, that's what came to mind. And let's say I pick position 1. That means it's going to look for these and see which one's smallest, and it will be 0, 1, 2. Right, so that's an example. Maybe I'll even say example. Okay, so that's index of smallest, and that's something we want to write, but we'll come back to it. Let's finish filling out sort. So we'll do a top-level design from sort. Okay. Next comes moving to the front, and I'm going to again pass the buck and say move to front a start index, and assume that method can work. Deal with it. Okay. I guess I should say, to make this very clear, probably we should have had this in our comment. Should have been nicer. Should have said move it to the front of the unfixed items. Okay. And then lastly, we'll selection sort the remaining unfixed items. So in this case, it'll be sort A, and what do you know? Start +1. It's the whole thing that inspired the creation of this method. We are not yet quite done. This is a recursive method, so we need a base case. So we'll say if a.length equals start, then return. All right. So that should be sort. Probably it'll work, but of course we'll have the test to check that later. Okay, so the next thing I want to do is jump into index of smallest. So this sounds seemingly like a fairly easy task. So rather than write a test, I'm just going to jump right in, see what happens. So let's start writing it. And what I'm going to do then is I'm going to use a pattern which is pretty common for finding minimum things. I hope maybe you've written code like this, where I'm going to say, okay, I'm going to assume the smallest things at start, in this case. So assume smallest string is at start. And then I'm going to refine that hypothesis by working through the array, using a for loop in this case. Now, if you are uncomfortable with for loops, by the way, it's a good time to head over to, not that, code, say homework code, homework 0b. I don't have permission, okay? How about now? Uh-oh. Okay, well, I guess you can't go do that because somehow the permissions have changed on that file. Okay, well, what you would do ideally is work on the forbidden homework that soon after this webcast we'll fix and make it unforbidden, where you can get a little more practice with for loops. Okay. So what we want to do is work through the array, and we'll say we want to go through the array, and we want to look for things that are smaller. And so what we'll do is say if ai is ever less than a mindex, then I now need to change my mindex to say, in fact, I is the new smallest. I'm refining my hypothesis and saying, okay, since the item at I is smaller than this, I gotta set aside mindex to be equal to I. Okay. It's probably a time to try and compile. Let's see what happens. So try and compile, and we get, okay, can't find move to front. Oh, okay, well, yeah, we didn't write that function. So create a dummy one real quick, move to front, and start in Mindex, and so I'll write a little comment here. You know, better while it's fresh in our mind. Let's see, moves item at Mindex into position start without destroying anything. We'll talk about that in a little bit. Why would it destroy anything? Yeah, later. Okay, so the next problem we'll run into when we do this is when we try to compile this, Java tells us we cannot compare strings with less than. Okay, that seems like a surprising language feature. How do we fix that? Well, as a student, this is probably what you do. And I don't think this is a bad idea. I think this is a perfectly fine practice to go through and say, okay, Java, compare strings, all right? How do I compare strings in Java? Perfect, okay? So I'll look at this thing. I am low on batteries, all right. So I've been using the equal operator to compare strings. And I ran into a bug, changed one to equals instead, and it fixed the bug. Is this bad? Okay, apparently a great question. Equals, okay. I want to know if a string is less than a string. Less than. Okay, less than. All right, whatever. All right. New Google search. Let's see. Java less than string. Let's see what happens here. How I compare two strings. Okay. I'm thankful that somebody seems to be looking for the same thing. So I have this string and this string. How do I say that one of them is smaller? Okay, we'll scroll through the answers. All right. You can use this. I hope that's not the answer because that looks long. Okay, if stir1 is lexicographically less than stir2, a negative number will be returned. 0 if equal. What? So a dot compare to b returns a negative number because a is less than b. All right. Yes, an integer is returned. All right. Well, okay. Let's do that. Copy and paste, and I'll adapt it to my purposes. Okay, so I had that, but instead of doing that comparison, I want to actually compare AI and a Mindex, and I guess this should work. You know, seems to be the same thing. I mean, this is just a string, so that should be fine. Okay, and I guess this thing gets turned into an integer, so I'll put it in a variable called comp. And so I guess if AI is less than a Mindex, comp will be negative, according to that Stack Overflow post I just saw. So what I'm going to do is say if comp less than 0, Mindex equals I. Okay, well now I'm starting to get nervous because I went to some crazy Stack Overflow post, and it seems popular. It's talking about contracts and stuff. I'm not feeling so good anymore. So I'm going to go back and I'm going to write a test for this method, right? I think that's probably a good idea. But first, I'm going to go plug in this computer. So let's take a short break. Okay, let's write this test. So we have private, static, in this case, again, void, test, index of smallest, right? So we want to write a test for this thing. And it's going to take no input, and we're going to say test the sort.index of smallest method. And it's going to turn out to be, thankfully, because of JUnit, a pretty straightforward process. So let's copy and paste this. In this case, we don't want to call sort, but instead we want to call index of smallest. And we're going to feed it input. We have to give it a starting position. Let's say 0, right? And we want to assign that to something, so we'll say that's our expected. And then what's our actual? Oh, sorry, this is our actual. Let's think to ourselves, what's our expected value going to be? All right. So we look at this thing. We say, starting from here, what's the smallest? 0, 1, 2, 3. G, yes, comes before I. So that's our expected. And then we can just, again, do org.junit.assert, in this case, equals. And you get some practice on that with homework 1, expected actual. Okay. So that's index of smallest. And then I'm going to add this down here so that it also gets called. Okay. Now let's try compiling this thing. That's a problem. What? It has private access and sort. Oh no. Okay. Well, as it happens, this is a pretty common problem when writing tests. In fact, there's a whole debate about what ought to do about this specific problem. And so we're going to adopt the easiest but kind of gross solution of just deciding that this should be public, all right? So it's as if we're a car manufacturer and we want to test the fuel, we want to make sure it's easy to test the fuel line. So we'll just run it across, the driver's lap or something, whatever. When they drive, they have to shimmy in under that fuel line. Sorry, we want to make sure that the fuel line looks good. It's a thing that we're going to accept for the moment, but later, in the not too distant future, we'll discuss an alternative, which is fine. All right. But for now, we're going to use this janky solution because that's what we can do. Okay, so try compiling again. More problems. What? 48 and 54. Oh, wrong class. Okay, so 48. Well, we forgot to return. That's certainly going to be a bug. We need to return the minimum index we were supposed to find. And then over here, move to front. You're supposed to return something. This shouldn't have been int. It should have been void. Because move, it's not supposed to return anything. It's supposed to do something. Okay. Compiles. Okay, let's see. By the way, I wasn't watching my warnings here. I should mention that occasionally you may be using a class and you get a warning that you're getting that you're using a deprecated API. In this case, I should have been using assert array equals instead of assert equals. Basically, it's that in an old version of this thing called JUnit, this was the way to do things. At some point, they changed their minds and said, in fact, no, you should now use a different, more specific function called assert array equals. And this old one was said to become deprecated. So that just means they're going to leave it around so they don't break any backwards compatibility. But they'll warn you about it and just say, don't do this because we don't think it's best practice. So anyway, kind of a digression, but my fault for not realizing I'd done assert equals instead of assert array equals. Okay. Okay, so now it actually is compiling. It's not giving me any kind of warnings. So we're not using any deprecated stuff, and our test is ready to go. Okay, so now let's try running it and see what happens. Okay, test sort. Wrong name. Okay. Test sort. Okay, it failed. It failed on line 28. That's down here. Darn it. Okay, I guess apparently a thing JUnit does, we learn through this experiment, is it terminates execution. So I'm going to comment this test out. Now, hackle should already be raised because that seems annoying. Like if I have to selectively enable and disable tests depending on what I want to really look at. And okay, point taken, and we'll see at the very end of this how to avoid that problem. So let's recompile. And really I should be using a makefile, I'm going to say. It would just be way better, but I didn't make one before today, so we both suffer. And what happens when we run it is nothing happens. So like in lab 1, whenever you found that your diff did nothing, right? Nothing is great. This is the equivalent of the green light. Might be a little less satisfying though. I mean, like I mentioned earlier that in the TDD world, if you're using the GUI, that like, oh, that's exciting, like a thing turns red, we get nothing. We get blankness, right? We're very like some kind of severe type of Buddhist that gets very excited by nothing occurring, right? But we will talk later, if you don't happen to be such a severe Buddhist, how we can get a nice little message. But for now, just be aware, running this thing, cool. That means that everything's in good shape, at least as far as our test is concerned. Now, a question that came up in real life lecture today is, are these tests any good? And the point with tests is they're not going to be exhaustive, right? Like they're never going to be perfect. We're going to build little tests and hope it builds our confidence, but we're never going to be absolutely confident. And in fact, there have been basic pieces. For example, in Java, there's something called binary search. It's a built-in thing for binary searching, a sorted array. and it had a bug in it that went undetected for well over a decade, right? So, you know, we don't expect our tests to be perfect, but perhaps this is, you know, good enough. Maybe, though, let's just throw in one more, though, because it's easy. I'm going to use this same string, and this time I'm going to say, instead of starting from the left, right, I'm going to start somewhere further over, because that seems like maybe a possible thing. Like if I look at this code and I say, where could I have bugs? I don't know. Maybe I messed up somewhere involving start. I mean, yeah, I see start, so probably not, but I'm going to here say, I don't know, 2. And then I'll run it, and then what do I, or sorry, I'm going to run it in my head, I guess, what I meant to say. So I'm gonna think about this thing and say, what's the expected one? So starting here, 0, 1, 2. Okay, so among these, what's the smallest one? It's again 3, right? And I guess I need another assert here. I can compile, and let's just double check. Make sure we feel real good about this. Okay, so I bet index the smallest is working. It seems like it's good. And so we'll proceed. Okay, so this seems good. So now let's move over to sort. Okay. To finish off sort, we need only one more thing, which is move to front. So let's do a little bit of philosophical thinking about what that function might look like. All right. Since we're doing a webcast, I'm willing to go there the extra distance. In class, I just kind of hand wave my way through it, but hey, let's check it out. Let's even make a copy of this slide so I have some more workspace. Okay. Let's say we have stuff not in sorted order. We'll give them all the same color. Let's see. Fill. Okay, yeah, of course. All right, so we'll use green for the moment to mean unfixed. And let's talk about moving things to the front. So we look across all these things and we say, hey, you're the smallest. So we're going to make you purple. And then these 4 here are going to be the remaining unfixed items. So we scan through this and we find, okay, this one right here is the new smallest. So we need to move her to the front. So how do we do that? Well, remember this is an array. And so in Java, that means we have like item 0, item 1. Item 1's real big, so we gotta push space a lot of times. Wow, this is real slow. Let's try tab characters. Okay. Wow, tab, so fast. So if we were to, say, do that, what we just did was tantamount to moving 3 items, which seems a little slow, right? And you can imagine for a bigger problem, this could be a huge problem to move a ton of stuff over. So you can see that overall 3 things moved if we do that procedure. So I'm going to put them all back. So I'm going to say rather than move this over and then move all these to the right, there's another thing we can do where we just swap them, right? So this is the classic trick. We'll be using this time and time again. It's a non-obvious trick. But all I need to do is get this guy, or sorry, this lady here over to this position. And doesn't really matter what else happens. Just she needs to be there, and that's that. Okay, so, you know, for clarity, I'm moving these. Probably I shouldn't, though. Okay, ignore that I did that. They'll just have to overlap, all right? So let's see the action one more time. The thing I'm going to do to move 3 to the front is swap her with this monstrosity. There you go. They have been swapped. Everyone's happy. Oh, no. Okay. I'm still getting used to Google Slide. There's weird. There we go. And then we'll mark this with the fixed color, which is equivalent to moving start forward by 1. Okay. So swap was the name of the game. So what I'm going to suggest is it's not even swap we want, but move to front. You know, I left it here to humor us, but really it's swap that I want. There is no built-in swap function in Java. So in this case, move to front becomes swap. And this is just going to now say swaps items in position start and mindex. Okay. To do that, Again, I'm going to employ something that I'm guessing a lot of you have seen. If not, I'm just going to rush through it, and if you want to, you can think about how you would do this. But I'm going to say, okay, string temp equals AIX. Oh, I should probably not call it a start and mendex now because, it's a general function. I guess these names are fine, but I'm just going to make them AIX and IY. The idea being here that, swapping is a fairly elemental operation. Okay, so here, string temp, I'm going to say is equal to AIX. AIX is equal to AIY. And AIY is equal to temp. And this is the simplest way that we can go through and swap two items in an array such that they actually end up getting moved. Okay, so this code right here, in other words, is just the same as swapping. So it's that. That's what we just did. Okay. So swap's done. Now I'm going to say I feel pretty good about swap. I mean, if I mess this up, I know it's getting late, right? It's past my bedtime, but I think I got it. Okay, so let's try compiling this. Good, compiles. Try compiling this. Good, compiles. And now finally, let's run our sort function, our sort tester. So Java test sort. And I actually need to be careful because we're doing things not best practices way. I need to switch back and have test sort running. So let's do that. Run it, and oh, there's a problem. Uh-oh. Expected God, but was is. All right. So let's see. God is in position 0. So somehow is getting up here. I'm getting stuck there. Oh, sorry. Yeah. Okay. So somehow this, is ending up at the front. That seems strange. Okay, so I'm gonna look at it real quick. I'm gonna say sort. I guess it could be this. Maybe I don't know. It's definitely not this. It's definitely not this. I don't think it's this. Well, there was something nagging at me actually earlier. When we did our index of this test method, right? The thing that nagged at me is that in both of these cases, the expected was the same, right? Like it didn't. There was a sort of lack of symmetry breaking I wanted is maybe how I'd put it, right? Like it doesn't matter what start I pick. It's always going to be this because this is the smallest, right? So it feels like probably our test coverage is just not as good as it could be. Like the behavior is just so flat. It should be something else. So I'm going to add a third test just to see what happens. And this time maybe I'll do cat, bat, horse, dog, okay? In this case, I'm going to ask for the smallest starting at, 1. It seems better than 0 somehow, like it's more general, I don't know. Again, just gut feelings. So I look at all this, I say, okay, from here to here, expected is going to be 1, right? So there's a different feeling here. These other two tests have the common feature that it scans through the whole thing and finds the end. Now I want it so it should basically, that the thing up here should be the winner. Okay, so again, copy and paste this. All right, and we have an error. Okay, we're not allowed to redeclare it. Just do this instead. And now we try running it. Okay. Now, actually, again, I've just changed test index of smallest, so I need to go all the way down here and switch this out. Okay. And again, you can already see like that seems ugly. The whole point of testing is to be dead easy, and this is not a best pattern, and we'll see the solution at the very end of this. Okay. So test sort. Okay, we still didn't catch a bug. All right. Interesting. Okay. Let's add one more. And say 2. And in this case, that's going to be 3, right? So dog. Okay. This is nice because now we have a different expected. Like again, it feels a little different. So that seems like a good sign. And we'll run this, and oh, found a bug. Expected 3, but it was 1. Okay. There is a bug somewhere in this thing. All right. Means we can go look at it. Okay. So the test tells us there's definitely some bug. I look at this thing and I say, okay, let's look at it. Now, if you were watching this earlier and you saw me make this bug and it was like a horror movie, like, no, be aware. I actually did it on purpose, but only during this webcast. So, you know, see if you can spot it. Okay. And I'll tell you it's right here. In fact, I should only be scanning from start. Okay. Now, the thing I was saying, sorry, before I got distracted, was during lecture today, I actually did not intend to do that bug, and it was like pretty scary. But the super cool thing is that I actually used this test-driven development technique, or used this unit testing here in order to find it, and it was very cool. Okay, so we try. Let's see if that fixed it. Indeed, it did. Less exciting here without all the tension in the room and all the faces staring at me and me already knowing the answer. But you can imagine how cool it was. Okay, so we feel pretty good about index of smallest now. I mean, again, it's not a perfect test. You know, we could write more exhaustive things. And so we'll go back and test sort. But I want to make one quick point, which is, notice how there's this repetitive pattern over and over, right? This should be maybe calling out to you that we want to encapsulate some functionality into yet another subfunction. So you can imagine having, maybe, I don't know if this really justifies it, but you can imagine having a little method that you just pass it an array like this of strings and a number, and it does all this stuff for you, right? That might be a nice idea. So always be looking out for encapsulations that you can do. Okay, so let's re-enable the sort test that we were failing because, in fact, index of smallest was wrong, and I strongly suspect it will work now. And we see, okay, good. Nothing's happening. We've won. Okay. So all that's great. Let's think a little bit about what we've achieved before we come back and make our code nicer so we don't have to do this thing anymore. So going back to our slides, what we did here is we finished off an implementation of sort. We feel pretty good that it works because it passed our very rigorous single sort test where potato is our God becomes God is our potato. Yes. Okay, so what we did, if you recall, we started off with main, set up these two functions, and then we jumped straight to creating test sort. The first thing that we actually finished in this whole procedure here was test sort. That's like the first thing we got totally done, or the zeroth thing. Once we were done with that, we went and started working on sort, and we were very bold and decided to jump in and finish index of smallest. And when we did that, though, we had that issue where we had to use that weird thing that we Googled on Stack Overflow, so we decided, oh, let's throw in a test. And I'm not really being silly there. I mean, I think it's really a thing that I do, right? Like, I feel like it's going to be pretty good. And then, I mean, I might literally go and find some code on the internet and then feel a little shaky about it, and that's fine, right? I mean, that's just part of development. So that's when you're going to throw in this test, and boom, eventually, after some interesting iteration, we ended up finding that there really was a bug. Then eventually we got done with swap and sort, okay? Now, the nice thing is with JUnit, it's pretty easy to set all this stuff up, right? It's not all that time consuming. And if we build big enough tests, we can build confidence, right? And you know, knowing what scale of test to build is just something that comes with practice. And so it's a thing you begin to start to feel things out. I guess a term people use sometimes is code smells. Never mind. No, this is already getting long. Okay. Okay. So let's finish this thing off. And before I do this last thing, I really want to reiterate this point up here that for these first few weeks, we're going to use stuff we don't fully understand, and that's okay. Because I'm about to do something horrifyingly weird. Okay. So we didn't like this for a few reasons, the way we were running tests. What we really want is we want a method or whatever. We want a function, method, same thing, right? We want a function that finds all methods that are tests, runs them, provides a cool little report. I've already alluded that there exists such a thing that's a GUI, but we're not going to officially use a GUI. I mean, you're welcome to go find it and use it, but we have a version that we're going to use for our class that Paul has helpfully set up, and I have a so these things, by the way, are called code snippets in Sublime. So you can say snippets and set them up. So I have a snippet here that when I press tab, it's going to set up all this stuff for me. And the only thing I'm left to do is type the name of the current class. Okay, this is not a thing I expect you to understand what any of this stuff means, except to say that this function right here, or really this function right here, it does all this stuff that we want it to do. Next week I think we'll be equipped to talk a little bit more about this. But for now, this is going to be a magic incantation that we're just going to accept as awesome. Okay, so we try compiling. And, the skeleton I give you for homework 1 already has this built into it, so you might not even notice it, but hey. Okay, and now let's try running the test this new, better way. Okay, Java test sort. Okay, no runnable methods. Okay, that's interesting. Well, that's not what I expected to happen at all. Okay, why are there no runnable methods? Test sort.class. Okay, this is a 53, 86, okay, 53. No runnable methods. I know what it is. Sorry. So how does it know to find all the methods that are tests, right? This function, what it does is it scans through all the things looking for things that are tests. We have to annotate them. All right. So what I'm going to do is say @org.junit.test. Okay. Yeah, trust me. And up here, I'm going to add that same thing. And what that does is it tells this giant crazy name here, this method here. It says what is worthy of running, right? It says these things are worth running. And this little @ sign here, I guess what I'll do is I'll describe it as this is a comment for machines, right? So this is a comment for humans. Star and their @ sign indicates a comment for machines. And we'll just leave it at that for now. So now let's compile, try running again. In this case, it's a very special thing. Like if I put anything else, like if I put, dot that, right, that wouldn't work. Has to be this particular comment. Machines are very picky. And we'll try running it. And now, okay, this is the bug I expected to get. Okay, so this is saying that test sort should be not static and should be public. Okay, so I'm just gonna, whatever you say, I'm gonna make this public. Okay, I guess I'm not too opposed to that, right? Like test sort is not really a world-facing thing, so if my method's public, whatever. And then I'm going to get rid of static, which we have no idea what that means. Really, maybe you have a crude idea, but next week's when we're gonna learn it. And then we're gonna go down here, change this to public, and get rid of this. All right, so all I'm doing is obeying what it told me. Let me try it out, and kaboom. All right, cool. So now instead of getting nothing way past, we get something. So if you're not part of the Nihilist Buddhist Club, this is your ticket to happiness, right? And this has a few other side effects. For example, I never need to comment anything out. And in fact, what it'll do is if you only fail a subset, rather than stopping at the first test that fails, it'll run all of them and provide you with an overall summary and even the time it took to run them. Okay? All right, here's a bonus thought that was not in the lecture today, so we didn't have time. You might notice we've gone pretty long for a lecture, but I figure you guys can 1.5x or 2x time this. So the last thing I want to do is, it is annoying to type org.junit.assert.whatever else over and over. That's not there. So what we're going to do is add something to the top of our file that's going to avoid the need to do that. In particular, I'm going to add these 2 lines, okay? And what you'll see is that you're welcome to put these at the top of all your files. In fact, the skeletons we provide do this. So what this top line does is it means that we no longer have to say, in this case, so this is going to save us the trouble of typing @org junit test. We only have to do test over and over. That looks nicer, right? Almost kind of intuitive. Mark a test with test. Great. And then what this other line here does is no longer do I have to type org.junit.assert.whatever. I can just use assert equals. And like magic, everything will work fine. Okay. And so in that way, you'll notice that now we finally converged on the kind of code that you'll be doing in homework 1. And for fun, I will continue deleting these manually. Okay. So let's rerun it, make sure everything is fine. Cool, good. Well, that's it as far as the coding goes. So let's debrief for a moment about what we accomplished today, and then you are free to return to whatever you're doing. Okay, some parting thoughts. How did my arm get up there? I hope I've convinced you that JUnit makes it easy to write tests. They can be pretty compact. It's a matter of just throwing down what you expect and what actually happens and calling some magic assert equals. Because it's so easy, I hope I've convinced you that you should actually write tests. I'm not saying that you need to go through and do the full-on test-driven development where you get yourself in the red zone and then green and the refactor and all that. I mean, you're welcome to. But I hope I've convinced you at least that there's some value in tests, right? Now, I don't think you should, even if you're doing test-driven development style, I don't think you should write too many tests, right? Like, you shouldn't think, how can I write the perfect test suite? I mean, that could be an interesting puzzle. And in fact, there are areas of research where the whole point is, how can we write really good testing software, right? But that's not what the point of our class is, okay? So don't go overboard. I want you to only write tests when you think it might save you some time, right? So for example, when we did the index of smallest method and we got a little nervous, that's the kind of time to write a test. Or if you write anything that's more than maybe, I don't know, a dozen lines or something, it could be not a bad idea. I think swap, when something's real small like swap, don't bother writing a test. I know in homework 1, you're going to be writing some tests for tiny functions like that, but that's really so I want you to get comfortable with JUnit. In lab and in the future, you'll develop your own sense of when you really need them. Yeah, well, all that said, I hope I've convinced you that testing is cool and not so bad, and I hope it serves you well. So let's call it a day on this webcast, and that is that.